We are continuing to talk about section 12.3 on measures of dispersion, and what I want to do is go back and do this same problem that we did the long way in the first video and actually do it with a TI-8384 calculator so that you can have an idea of how this will work with the calculator. Once we do that, I will take you to an example of a table, a frequency table, and we will calculate a standard deviation from the table. The process is a little bit more involved if you're doing this by hand, and we can actually see an example in the textbook on page 657 of doing the standard deviation from the table and what you have to do in order to calculate that. So just be aware that it is a little bit more involved, but there is an example at the top of page 657. So if you choose to do this with a calculator, I think you're only going to see maybe one question possibly on this in the homework. So let's begin by going to, I want to go to the calculator. And what we're going to do is we're going to take a look at the temperature problem, my office temperature. And so I'm cutting a little bit of the calculator off here, but I think you can see most of it. And where we begin is with the stat key. And we're going to choose edit, which is what is highlighted. So I'm just going to enter. And I want to put the numbers, the temperatures for the 5 days in the calculator. So I'm entering 52 and 65 and 71, 86 twice. So those are my 5 temperatures. Now I'm going back to the stat key, and this time I want to choose calc. So I'm using the right key to move it to the right, and I want the very first listing, one variable stats. So I'm going to enter since they're correctly selected, and we're going to enter one more time. Since everything I have is in list 1, you can just press enter. If it were in a different list, we would have to make sure we chose the correct list. Okay, so we can see that we were correct. X bar was 72, and our sample standard deviation that we got was 14.5, and there it is. Notice the population standard deviation is actually below that, and it's a little bit smaller. It's because you're dividing by a larger number. Instead of n-1, you're dividing by n. So the calculator will give us those values. So I wanted to point that out on the TI-8384. It is very easy to use it when it comes to statistics, particularly if you're comfortable using a calculator. Now I want to use a frequency table, and I'm just going to create it as we go here. And so let me go back to, I'm going to quit and clear everything out. Okay, so suppose we have a frequency table, and I'm just going to make one up as we go along. And what I'll do is again go to Stat and Edit. Now to clear this first list, what I'm going to do is go up and highlight the list name. I'm going to press clear and enter, and that will clear the entire list. Okay, so what I do if I have a frequency table and I'm calculating the mean and the standard deviation from the frequency table, suppose that we have a value of 13 and a value of 10, a value of 7, a value of 4, and a value of 1 in our frequency table. and that our frequencies, and let me move over to the next column, our frequency, we have 3 13s, we have 4 10s, we have 7 7s, we have 5 4s, and we have 2 1s. Okay, so what I have done is I have put these into the L1 and L2 category. I have my actual numbers or data values and then the frequency of those in the second column. Okay, and what I want to do is I want to calculate the mean and the standard deviation for this set. So what I do is, again, I go to Stat, and then I'm going to go again to Calc, so I'm going to move over. I want one variable stats. I'm going to enter only once now. When it comes up, because we're using the first two columns, we have to say second 1 to get L1, comma, second 2 to get L2. So what I'm telling it is the data values are in L1 and the frequencies are in L2. Okay, then I press enter, and we can see the mean for this particular group of data values would be rounded to 7.1. The sample standard deviation is 3.6 if you rounded it just to one decimal place. Okay, I also want to point out that down here we get what is called the 5-number summary. So it does give you the median. You just scroll down. It'll give you the minimum number, the maximum number, the median, and then something we'll talk about in a future section, the first and third quartiles. So you can also check your median there. So hopefully if you have one of these calculators, you may find this particular part of the lecture helpful, simply because you can calculate it very easily with the calculator. Okay, so now we need to go back to our notes to talk about the last part of the notes. I've got to move a few things around here. Get back to the notes. Okay, the last thing we need to talk about is Chebyshev's theorem, and this applies to any distribution. And I got an extra letter in here. So you may want to correct that. What it says is the proportion of any set of data lying within k standard deviations of the mean is always at least 1 minus 1 over k squared, where k is any positive number greater than 1. So what we're talking about when k is 2, we're talking about the data that lies within 2 standard deviations of the mean. And the way we calculate that is we put in place of the k, we put a 2, and that gives us 1 minus 1 over 4. And of course 1 minus a fourth leaves us with 3/4. So what we're saying is at least 3/4 or 75% of all data will fall within 2 standard deviations of the mean. And note that this is for any type of distribution. It could be a uniform distribution, it could be a bell-shaped distribution, it could be right or left, or it could be like a bimodal distribution. So it's saying at least 3/4. And so if we're looking within 3 standard deviations of the mean, we plug in a 3 for our k, and it's going to be 1 minus 1/9, which is 8/9. What we find is at least 8/9, which is about 89% of all data, fall within 3 standard deviations of the mean. And again, this is for any type of distribution. It can be bell-shaped, it can be a uniform distribution, okay? It could be bimodal, where we have 2 tall bars. and then some shorter ones. So any of those distributions, the Chebyshev theorem will apply. So that ends the lecture on section 12.3.